right, everyone. At this point, it is time to recap everything we've done so far this school year. So we're going to kind of work through review 1 here together. And just this video is going to be designed to help us be able to do well on our quarterly next week. So remember, in this first question here, I'm looking at if a is equal to 3x squared plus 5x minus 6, and b is equal to negative 2x squared minus 6x plus 7, then a minus b equals. Well, first thing we're doing here is we're taking a. A is this whole entire piece here. So I'm taking 3x squared plus 5x, subtract 6. Now, what we should also keep in mind is that we are subtracting everything that follows in B. So everything that's following in B here is this negative 2x squared minus 6x plus 7. So in that first parenthesis, there's nothing in front of the parenthesis, so it's really fair game for the 3x squared plus 5x minus 6 to just drop out. But what we really want to be mindful of in this next part is that you're distributing this negative to both pieces. So you have negative times a negative makes a positive 2x squared. Negative times a negative again makes a positive 6x. And finally, negative times a positive is going to make a negative 7. Now, once we've made it to this point, you're combining what's known as like terms. Remember, a like term is either it's a number, it's a letter, or it's a letter with the same exponent. So here, I can see that these two both have x squared attached. So I'm just adding the coefficient in front, so the number in front, to get 5x squared. Next, we see that these two numbers, these two terms rather, both have an x and just a single x without a squared, without an exponent. So we're combining the 5 and the 6 to make 11x. And finally, our negative 6 minus 7 more is going to get us negative 13. So as I'm looking at that, that means my choice is going to be choice 2 here. And notice it's also written in standard form. So recall, standard form is when you write your polynomial from highest to lowest exponent. So the degree there would be 2, and my constant would be a negative 13, while my leading coefficient is 5. Just some fun vocab to remember. Now, number 2 is strictly a calculator question. So what I would be doing is I would be plugging each one of these into my calculator as I go. Now, if I look at this first one, L plus M. So I'm taking this L plus M. That's the equivalent of radical 2 plus 3 radical 3. And now as I take a moment, I'm going to be plugging this into my calculator. So you should be doing the same in here. Now remember, you can use your Calculate 84 app if you have access to it. As I add those together and typing it into my graphing calculator, I'd have a number that looks like 6.610365998. Oops, just kidding. Oh, wait, 9851. And that's not really where it ends, but that's all the pieces that your calculator can hold at one time. So this is what's an example of an irrational number. As I look at that decimal, there's no pattern. It goes on forever. It doesn't look like it's going to end anytime soon. So that's definitely not going to be our rational expression that we're looking for here. So for number 2, I'm going to do the same thing. I'm typing this M, which was 3 radical 3, plus radical 16 into the calculator. And we end up with 7.9372539. 332. And again, it's not that it's ending at that number. It keeps going, but our calculator just has no room to continue that process here. So again, that's another example of an irrational number. There's no pattern. There's no logic to what number is coming next here. So we kind of keep it going. When I get to n plus p, I'm looking at the radical 16 plus radical 9. And when I do that, we end up with 7. That is definitely an example of a rational number. It's a whole number. It's an integer. All of those things combined, right? We might never even realize that the square root of 16 was 4, while the square root of 9 is 3, which is what gets us our 7. So you have no crazy decimals stuck under that radical here. So this is what a rational number would look like. In our next one, we have the owner of a small computer repair business has one employee who is paid an hourly rate of $22. The owner estimates his weekly profit using the function 8,600 minus 22x. In this function, x represents the number of, remember, this number 22 is how much they're paid on an hourly rate. That's the same as saying each hour. When you have that each or every hour, that's what your slope represents. And we know that our slope equation really comes from our slope-intercept form of y equals mx plus b. So it's just like I rewrite this, that it's like negative 22x plus 8,600, which makes sense because an owner is not going to be receiving profit from what they're paying their worker to do. So it's going to be choice 2, hours worked per week by that employee, right? So it's each hour, which is why it's not choice 4. It's not about the customers. And if you were serving more customers, right, we'd be making money, not losing it. And same with the computers, rather, we wouldn't be losing money there. Now in number 4, this is like a nice real trial and error one as you go through when you're reading it. It says the graph below was created by an employee at a gas station. Which statement can be justified by using the graph? So first it says if 10 gallons of gas were purchased, $35 was paid. So that's when I zoom in over here and I go to where 10 is on the X. Now remember, I always use that to go up to where we are on the graph. Now, it's clear here that that is not $35. That's a little bit above. I'm going to say it's maybe closer to like halfway point, so $37.50. So choice 1 is a no-go for us. In 2, it says for every gallon of gas purchased, $3.75 were paid. Well, as I look here, I'm trying to look at 1 would be around here. That might be hard to determine right now. So I'm going to pause on that number 2, and we're going to come back to it and just kind of look at our other options for a quick moment. It says in choice 3, for every 2 gallons of gas purchased, it was $5 paid. Well, so at 2, same thing we did in number 1. We definitely know we're higher than we were at 5. So it can't be choice 3. So we're down to a 50-50 shot. So when I look into this last one, if 0 gallons of gas were purchased, 0 miles were driven. Well, if I look here, 0, 0, remember it says 0 number of gallons of gas were purchased, but that's not what the Y value is. The Y value in context is the cost of the gas, not anything about the miles driven. Now, yeah, if you have no gas, maybe you can't drive, but think about every time you get in the car with someone. You don't always have to gas every time because sometimes you have some leftover gas. So in this case, just because you didn't purchase it doesn't mean you might not already have the gas. And it's not what's on your y-axis. So I'm automatically crossing off that one. And I'm revisiting this choice 2, which is going to have to be our answer. Let's talk about why that works. Now, it might be hard to guesstimate where that purple point is on my graph, but I'm going to go find a point that's pretty nice, like this 15 and 4. We're going to think about our average rate of change. If I take 15 and I divide that by 4 in the calculator, I'm going to end up with 3.75. I can do it again just to kind of follow up. At this point here, I'm looking at 30 as the y, and in this case, it's 8 as the x. Same thing. If I look at any nice point and divide those, I'm going to end up with this rate of change each time. So that's how we know each gallon of gas was costing $3.75. Okay. Now, number 5 is similar to what we saw in number 1. However, key wording is a factor of this one. Subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. Take a moment here. Think about what your key word should be. Yeah, we definitely see subtract as an important word in trinomial, but our key word is from. This indicates that I'm subtracting the first term given from the second. So we're going to write 3x squared plus 8x minus 7 first. And we're going to subtract it by the part that was in the beginning, that 5x squared plus 2x minus 11. So be careful with that mathematical language, right? We want to be sure that we notice those kind of key terms and those key factors of how we're going to go through this. And then it's just business as how it was in that first question we looked at. We have 3x squared plus 8x minus 7. That first parenthesis just becomes free because there's no piece in front of the parenthesis to kind of distribute. You don't have to worry, but we do want to make sure we're paying attention to that in a second. We are subtracting each and every part inside of that trinomial. So we're going to make a negative 5x squared as well as a negative 2x. But then when we have this negative and negative, that's going to become a positive 11x. Once we're at this stage, you're ready to combine your like terms. Again, your like terms are going to be the letter that matches with the exponent that matches. So x squareds are going to come first. I try to start with the highest exponent because I also just like to rewrite it in standard form. It didn't ask me to, it just asked for a trinomial, which we know is a polynomial with 3 terms, right? Like tricycle in that case. So 3 minus 5 gets me a negative 2x squared. 8x minus 2x gets me a positive 6x. And negative 7 plus 11 is going to get me positive 4. So we get that. It's a trinomial, definitely, because I've simplified it down to 3 terms. And I even bonus put it in standard form from highest to lowest exponent. I like to kind of keep that idea as I'm going because it just helps me organize my ideas. All right, and the next one we're going back to graphing. So as we get back to graphing here, remember that this is already in our slope-intercept form of y equals mx plus b, which means my slope is the number that's in front of x, so that's 2/3, and b is your y-intercept, that negative 4. B essentially is where you start on the y-axis. So when I go to do this, I'm starting at negative 4. So I go to y, that's the vertical line here. Negative 4 means I'm going down 4. So that should be my first point. Remember, with your slope, it's either up or down. So it's positive. So this one's going to be up. And we go to the right from here. So we're going to go up 2 and 1 and 3 to the right. Excuse me. So up 2, 3 to the right. Up 2, 3 to the right. Up 2, 3 to the right. You can also work in reverse and go down 2 and 3 to the left, down 2, 3 to the left, and down 2, 3 to the left. Now you can get all the points on your graph if that makes you feel better. Remember, we aim for a good solid 5 points if we can. Sometimes we can't reach all of that. We give this arrows because there was no restriction, and I go that step further and write y equals 2/3 x minus 4 and label our line here. Now remember, if you get stuck on doing that, this could also be completely plugged into your calculator. So for a moment, just go into your calculator, have out either your graphing calculator app or your graphing calculator with you, and go to y equals on that calculator. Type in 2/3 x minus 4, and then hit the graph button. You'll see a line that should model the one that we drew, but you can also go to second table, and as you're in that second table, you can see these points that we ended up plotting. As you look, you'll see at 0, the y value was negative 4. When x was 3, the y value was negative 2. When x was 6, the y value was 0. And in the opposite direction, even as negative 3 for x, you'll be down at negative 6. So you can just plot those points by counting as well. Now 7, we still want to do the same thing, but we need to isolate that y characteristic before we're able to go ahead and graph. So just like before, our goal is to get it into y equals mx plus b mode. If we can get it into the form y equals mx plus b, then I can either plug it into the calculator like we just spoke about, or we can graph it the same way we did in the previous problem. So to isolate y, we first want to move anything that does not involve y out of that side. So I'm going to subtract 6x from both sides, and I also subtract it to the opposite side of the equal sign. It's a positive 6x. The opposite of a positive 6x is a minus 6x, which is why I'm crossing that out. Then I'm left with 3y to the left of the equal sign, and I'm going to put the negative 6x in front because that's our form, and I'm going to have plus 12 following. Now we're really close to getting y by itself at this point. The opposite of times 3 here is going to be dividing by 3, but keep in mind you're dividing each and every part by 3. We will cancel that on the right so that y is equal to, and now you're just doing negative 6 divided by 3 in your calculator. We will get negative 2x. Remember, you're not plugging x into the regular calculator section. X only can be plugged in when you're using y equals. It will not work for us here. So you don't want anything like negative 6x plus 12 divided by 3. You want to do it individually. 12 divided by 3 is 4. And here, now we're ready. We've found our y-intercept. So my y-intercept is a positive 4 this time. This is where we start on the y-axis. So on the y-axis, I'm going up to positive 4. Now our slope is a negative 2. It can also be considered a negative 2 over 1. So in here, we're going down 2 and 1 to the right each time. So I'm coming down 2, 1 to the right. Down 2, 1 to the right. And I'm going to keep that pattern moving solid. I'm going to do the same thing in the reverse direction. And as we do that here, I'm going to make sure there's arrows on both ends because this is going on forever. And you could write it as y equals negative 2x plus 4. If you wanted to write it what it was in the beginning, if you want to write 3y plus 6x equal 12, that's also equivalent. We haven't changed the equation here. We just rewrote it into the form of our slope-intercept form. Now, since we're going to continue on with these graphing ideas, we're getting to our piecewise functions. Now, remember, our piecewise functions are exactly what the name is here. They're in 2 pieces. Now, when I go to set this up, I'm going to tackle it one step at a time. I'm going to set up my table for x and y values just to help me organize my ideas. The reason I do this is because I'm very specifically being told that I'm starting at negative 3 and ending at 0 for the x's. If negative 3 is less than x and is less than or equal to 0, that means x has to fall somewhere in between those number sets. So I'm going to write out negative 3, negative 2, negative 1, and 0. At this point, I'm going to have out my calculator again. So have out your graphing calculator in hand. We're going to go to y equals, but we're only going to plug in negative x minus 4. So once I plug in that negative x minus 4, I can look at the graph and see the line that has been formed. And I can also do second graph. So that way I have my x and y variables to kind of get the points, the coordinate points that fall on this graph. So at negative 3, when x is negative 3, y was negative 1. At negative 2, y was also negative 2. At negative 1, y was negative 3. And at 0, we'd be at negative 4. So now I'm going to graph this section first. So from negative 3, negative 1, I have to be careful though. When you just see a less than and there's no line underneath, that negative 3, negative 1 is going to have an open circle. So at negative 3, negative 1, I've drawn a circle with an open value to it. Anything in between these two numbers can be closed. So at negative 2, negative 2, I'm going to close that. At negative 1, negative 3 will close. And I'll be able to close at 0, negative 4, because there's a line underneath there. X is less than or equal to. Or equal to indicates that it's included. It indicates that it's a little bit more work to draw the line underneath, so it's a little bit more work to shade in our circle there. And I connect those values. So that's my variable from negative 3 to 0. We're going to do the same thing, but now for the second half. So for my second piece, this time it's starting at 0, and it's just going until 2. So we only have 3 points to worry about here, but same thing again. You should be going into y equals and plugging in 2x plus 3 now. And when we go to a second graph, we can see our x and y table there. So when I plug in 0 for x, the y output was 3. When I plug in 1, we get 5. and at 2, we get 7. So now I have those points to plot. Again, at 0, you'll see that 0 less than x. That means 0 is also going to be open. So at 0, 3, we'd have an open circle. Now at 1, 5, it will be closed because it's in the in-between. And at 2, 7, it will be closed because there was a line underneath the inequality. So with that inequality, we can close that out. And we have our piecewise function shown. There is 2 pieces to consider. So there's 2 pieces that are on my graph. And you'll notice it's still a function because even though at 0, there was 2 dots placed on our graph, there's only one that is filled in. So the filled in one would be the one we would evaluate in that case. All right, last question for this first quarterly review here. We've done this question a bunch of times, but just let's throw it back and remind ourselves how it's set up here. So the graph below models Craig's trip to visit his friend in another state. In the course of his travels, he encountered both highway and city driving. Based on the graph, during which interval did Craig most likely drive in the city? Now keep in mind, driving in the city, think about what it's like to be in the city. It's a little bit more crowded. There's a lot more traffic lights. There's towns, there's people. It's a little bit going on. So I would think that you would be driving a little bit slower there. So the slowest increase in distance here is going to happen from this D to E. We don't want to be at a dead stop like we are at B to C because that means like we're not moving at all. There's no acquired miles happening. But in here from D to E, then explain your reasoning. We need some words to back this up. So anytime you see explain, we want words. And we can say city driving is slower due to, and you can say for many different reasons. I'm going to say more people. You could say more traffic lights, more traffic just in general. Something along the lines of why we know the city is going to be a little bit slower. In my next section, it's asking me about from B to C, right? So B to C shows me that flat line, which means we're not going to have a slope of anything other than 0. My slope is 0 because I'm not adding on any miles traveled. So this means that we are stopped. There's plenty of reasons why you may be stopped, and you could write any of them as your reasoning. So some things that you could include were that they stopped for food. Maybe there was an accident on the road. Maybe they got stuck in construction. Anything along those lines. I'd avoid something like a red light because even though you do stop at a red light, notice that you're stopping from hour 2 to hour 3.5 here. So if you're stopping for an hour and a half, if you're stopped at a red light for that long, maybe the red light is broken. So I would avoid that. But I'm going to say for snacks. Okay, if you're going to another state and you're driving for multiple hours, you might just need a nice little refuel. Or maybe you need a rest. Maybe you're tired and need to take a quick nap. Last one is asking us about our average speed. So when it says the average speed of the entire trip, remember average speed, average rate of change is all the same as our slope formula. And when you use your slope formula, you need 2 points. y2 minus 1 over x2 minus x1. As I look at that, I'm going to come to my graph and get 2 points that make sense. Again, we wanted the entirety of our trip, so we start our trip at A. So we're starting the trip at the point 0, 0, which makes sense. If we haven't driven any hours yet, we haven't made it any miles. Now, we finish this trip at 230 miles after 7. So, I want to put the x value first. Silly me, almost wrote it in the wrong spot. 230 as the y. And so now we're just plugging into this formula. Again, it's the same as your slope formula, so all we're doing is taking 230, subtracting 0. We're taking the y's, and we're taking 7, subtract 0 on the bottom there. And then I plug into my calculator. Whether you use alpha y equals and write the whole thing in, whether you just take 230 divided by 7, we end up with 32.857 1, 4, and it keeps going. It did say to round to the nearest tenth. So when you round to the nearest tenth, remember that is the decimal place that, if you think about having 10 cents, is 2 decimal places, but you use that second one here to help you round up. So the 2 decimal places, you use the second one to help you round up, but think about how many zeros are in 10. So when you're thinking about how many zeros, there should be only 1 decimal place. So this is 32.9, and I want to put the context in here. Whatever y was, miles per x is hours. So the average rate of change is 32.9 miles per hour, but that's how much they're traveling in that time. All right, stay tuned for the other videos that will help you get ready for our quarterly coming up. And thanks for watching, everyone.